This problem has alternating signs. The first term is positive, and then from then on it alternates between negative and positive. See, positive, negative, and so on. This is because each term is multiplied by negative 1 raised to k minus 1. This means that when k is an even number, k minus 1 is an odd number, and negative 1 raised to an odd number will always produce negative 1, making the entire term negative. This is the opposite when k is an odd number, meaning the whole term is positive. In the first sum notation, the series begins with k equals 1, meaning that negative 1 is raised to 0, and anything raised to 0 will equal 1, making the entire term positive. In the second sum notation, k begins at 3, which is an odd number, making negative 1 raised to 2, which will produce positive 1, making the entire term positive. There are also many different ways in which sum notation can be written to represent every sequence based on how the starting value changes. In this sequence specifically, we change the starting value from 1 to 3. This still works with the negative 1 aspect as previously mentioned, so that was able to be kept the same. But it meant that we had to divide 2e raised to the k by e squared, so that when simplified, they would equal the same number for each term, as e squared cancels out the extra second power brought on by the higher starting number. As can be seen, when the values are plugged in based on the starting value, they produce the same sequence shown above.